Hey there, everybody. Let's get started on 4.6. This is limits at infinity, like doing limit as x goes to plus or minus infinity. We're going to see some functions increase or decrease without bound as x goes to plus or minus infinity, but some functions approach a specific value. I've got four basic ones right here. If we do limit as x goes to infinity of x cubed, we get positive infinity, but if we take the same function and we do limit as x goes to negative infinity, we get negative infinity. Then if we do like where the x cubed is in the denominator, it doesn't matter which sign we do, plus or minus infinity on our limit, we're going to get a 0. And if we do limit as x goes to plus or minus infinity of 4 minus 1 over x, we're going to get 4. We're going to see, so in some cases it approaches value, and in some cases, it approaches infinity. So we're going to talk about that right now. So if a function gets arbitrarily close to a limit L as x gets sufficiently distant from 0, like really large number or really negative number, we say that f of x has a limit at infinity. Limit as x goes to infinity, f of x equals L, or limit as x goes to negative infinity of f of x equals L. Generally, if it approaches L on one side, a specific value, it approaches L on the other side. There are some exceptions, like piecewise functions. We'll see one in a second. That's not a piecewise function, but has different limits on each side. And if the limit is actually approaching a value as we go to infinity, whatever that value is, like L, we say that the line y equals L is a horizontal asymptote. And while we can cross, or we can't cross vertical asymptotes, we can cross horizontal asymptotes. Horizontal asymptotes just means it's what the line tends to navigate towards as x goes towards infinity. As you can see here, the further we get from the x-axis, the more those values are following that dashed line, okay? So let's take a look at doing some examples. For each, we're going to evaluate the limit as x goes to infinity and limit as x goes to negative infinity of f of x. If there is a horizontal asymptote, which I like to call h dot a dot, because you're going to get tired of writing that shit, say what it is. Our first function is f of x equals 7 plus 1 over x squared. So when we do limit as x goes to infinity, 7 plus 1 over x squared, what's going on here is like this bottom part is going towards infinity. And collectively, as the whole thing goes towards infinity, or that whole thing goes to 0 as the bottom goes to infinity. So this is approaching 7. So we will have a horizontal asymptote of y equals 7. Should this be any different if I plug in negative infinity? 1 over a really small negative number isn't any different than 1 over a really positive negative number. Or 1 over a really, I should say, 1 over a really large negative number isn't any different than 1 over a positive negative number. But the squared is actually going to do this. It's going to get rid of the negative sign. It's going to be the same either way. Let's take a look at f of x equals sine x over x. Do you remember how to do these? Pause and think about it. Well, if you said squeeze theorem, you were right. We're going to say negative 1 is less than or equal to sine x, which is less than or equal to 1. We'll multiply both sides by 1 over x. Multiplying by 1 over x. And then we will take the limit as x goes to infinity. And this goes to 0. This goes to 0. And so we have 0 is less than the limit as x goes to infinity of sine x over x, which is also less than 0. So that limit is 0 by the squeeze theorem. And if you do the math, you will see that the limit as x goes to negative infinity is also 0. One way to do it is do a little u substitution, say u equals negative x. And so if you do u equals negative x, as x goes to negative infinity, u is going to positive infinity. And you'll see that the math still works out the same. So like x is the same as negative u. And your math will still work out the same. Let's take a look at f of x equals tangent inverse of x. So if we look at the graph of tangent of x, we see this. So as we get close to pi over 2, oh, that's neat looking. What is that? Like pencil lead. Oh, that's good. Like graphite. That's kind of neat. As x gets close to pi over 2, from the left side, the negative side, tangent x is going to infinity. So we could take advantage of that, as we have here. And if that's the case, when we do the inverse, the domain and range flip, domain and range swap with infinity or inverses. So these two swap. And say inverses. There we go. And if we do it, show it, look at it going to negative infinity or negative pi over 2, we see it's going to negative infinity. So we get the same thing there. If we look at the graph of tangent inverse, we see this. There are actually two horizontal asymptotes, y equals pi over 2 and y equals negative pi over 2. Okay, it's kind of crazy. It's crazy talk, I tell you. So sometimes there's differences. This is not a piecewise function, so it's just like in some cases it's different. Next, we're going to take a look at infinite limits at infinity and end behavior there. I'll make another video real quick.